Our oceans act as a carbon sink. As gases are exchanged between the atmosphere and the surface of the ocean, CO2 is able to dissolve and reacts with the surrounding ocean water. In fact, it is thought that around a quarter of the anthropogenic releases of CO2 can actually be sequestered by our oceans. However, as CO2 levels continue to rise, there's a limit to how much can be stored. Processes like the sinking of marine snow down the water column can transport carbon away from the surface, where it can remain stored away from the atmosphere for long periods of time. Here you can see the cycle of carbon within the ocean, where downward arrows represent carbon that can remain away from the atmosphere for hundreds or thousands of years. The sinking of small particles through the water column is one important way that carbon is stored and sequestered within our oceans. But what role do large marine organisms like whales play in this carbon cycle, and how may their conservation be a strategy in carbon sequestration? Whales are able to store carbon in multiple ways. Consider tree planting as a form of carbon sequestration. When the trees are planted, they uptake CO2 from their surroundings and store that carbon as biomass. Similarly, when whales eat, they uptake carbon from their food and store it in their tissues. Due to the lifespan and biomass of whales, this temporary storage of carbon may be significant in dictating how much total carbon the oceans can store. When the biomass of whales is decreased due to hunting, there is less available biomass in which to store this carbon. Thus, whale conservation may be one way to increase or at least protect the current levels of carbon storable in the ocean. Whales also play a more long-term role in carbon sequestration. When whales die naturally, they often sink through the water column due to their mass and reach the ocean floor. Here, the carbon they hold may remain away from the atmosphere for long timescales. Whales may play a role in long-term sequestration of carbon during their lifetimes as well. When whales come near the surface to defecate, they introduce limiting nutrients such as iron into the photic zone, thereby enhancing primary production. When primary production is enhanced by supporting larger biomasses of phytoplankton, more CO2 can be removed through photosynthesis, thereby sequestering more carbon from the atmosphere. But how about the CO2 that whales produce due to cellular respiration? A study published in the Royal Society quantified this removal versus addition and found that sperm whales in the Southern Ocean remove 2 times the amount of carbon from the atmosphere through export than they add through respiration. This means that whales can act as a carbon sink. Why is this important? As levels of CO2 in our atmosphere continue to rise, it is important to understand where to focus our efforts. Conservation of whale populations may be one strategy in increasing oceanic carbon sequestration, and knowledge of the processes and metrics behind whale-driven carbon sequestration can inform policy and conservation efforts. One potential application of this concept is the integration of whale conservation in the carbon market, an idea introduced by oceanographer Andrew Pershing. The carbon market is a system in which large emitters of carbon dioxide are able to trade permits of carbon emission in order to stay below a general emissions cap. By integrating whale conservation into the carbon market, companies could gain emissions credits by taking actions that support protection and growth of whale populations. The general schematic can be seen here with trees, where trees sequester carbon through photosynthesis, and landowners gain carbon credits for planting these trees. A similar approach can be taken with whale conservation. What kind of return can we expect from these conservation efforts? According to oceanographer Andrew Pershing, if we allowed whale populations to recover to their 1900 levels prior to the commercial whaling, whales have the potential of sequestering 9 million tons of carbon in their combined biomass. That is equivalent to planting 11,000 square kilometers of forest. Pershing notes that this magnitude of sequestration is comparable to forest-related sequestration schemes and is something to be seriously considered. By allowing companies to receive carbon credits for whale conservation, we can not only ensure that carbon is sequestered, but also support the rebuilding of a critically diminished population.